All right, today we are going to talk about solving systems using matrices. Also known as matrix. All right, so a matrix is a rectangular array of numbers described by its rows and columns. So, for instance, we've got a matrix like this. Would be described as a 2 by 3 matrix. All right. The 2 being the rows, okay, and the 3 being the number of columns. Columns are vertical, rows are horizontal. All right, so this would be called a 2 by 3 matrix. You could see it described as this. All right, with the subscript 2 by 3. So that would be a matrix that has 2 rows and 3 columns. Each number in a matrix is a matrix element. So if you were asked to identify, let me double check the wording for you. Identify the indicated element. Would be a question. If you're asked to identify the indicated element and you are asked for element 1, 2 or A sub 1, 2, we're looking for the element in the first row, second column. So if I highlight this yellow, this 1, 2, we're looking for first row, all right? Second column would be this element right here. It would be 4. If you are asked to identify element 2, 3, that's going to be in row 2, column 3. So again, the rows are horizontal. So row 2, column 3, that element is a 3. Everybody see that? When you're asked to identify the indicated element, you're finding a number value located in the matrix based on this subscript. So if we had an element 2, 1, that is row 2, position 1, would be right here. That would be a 6. Everybody okay with that? All right. Now, you can represent a system of equations using a matrix. Let's say you can represent a system using a matrix. All right, so if we had a system, and let's say we had something like x plus 3y equals 7. And 3x plus y equals negative 8. And we were going to use a matrix to represent this system. Here's what our matrix would look like. We go bracket. Now, we're going to use the coefficients. We're going to use the numbers in front of the variables only and the constants. So we're going to write this x plus 3y equals 7 as 1, 3. This vertical line represents the equal sign, and 7. We're going to represent this 3x plus y equals negative 8 as 3, 1, negative 8. And we're going to close the bracket. All right, so on the left, we have a system of equations. On the right, we have a matrix representing that system of equations. Now, kind of the key to converting from a system to a matrix is that you have both equations in the system in alphabetical order. Okay, and here's what I mean by that. So let's take this system. We're going to take the system x minus 3y x minus 3y plus z equals 6. We've got an x plus 3z equal to 12. And a y equals negative 5x plus 1. All right, this is where you need to be a little bit careful. We want everything in the order x, y, z equal sign constant. So the first equation is good. All right, we've got an x, we've got minus a 3y, and we've got a z, we got equals 6. So when we write this as a matrix, this first row is pretty simple. We got a 1, we got a -3, we have another 1, an equal sign symbol, the vertical line, and then we got a 6. Now, in this second equation, the coefficient in front of the x is a 1. We don't have a y, do we? If there's no y in the equation, it's because there was a 0 in front of it. So in our y column, we go 0. Coefficient of z is 3, and we're equal to 12. Now, this third equation, let's take this third equation and add 5x to each side. We're going to put it in xyz form. So we get 5x plus y. There is no z, and we're still equal to 1. So converting this to a matrix, in the first column we get a 5. In the second column, the coefficient of the y is a 1. There is no z, which means there's a 0 in front of the z. So we go 0. And our constant is a 1. All right, so does everybody see how that works? When everything needs to be in alphabetical order. You may have to manipulate these equations to get them into alphabetical order. And if any equation has 3 variables, then all the equations have 3 variables. And the variable that's missing has a 0 in front of it. All right, so let's look at one more of these, and then I'm going to give you a couple to practice on your own, and an electronic assignment to get you started in this second term. So let's take this system where we got 4x minus y plus 2z equals 1. We got a y plus 5z equals 20. If it's y plus 5z equals 20, let's just put the y here, plus 5z equals 20. And then we got a 2x equals negative y plus 7. 2x equals negative y plus 7. All right, so when we write this matrix, in our first row, we got a 4, a negative 1, 2, equal sign, and a 1. In our second row, in our coefficient for the x is a 0, 1, 5, and 20. And then in this third equation, we need to get this y on the other side of the equal sign, so I'm going to add y to each side. And I get 2x plus y equal to 7. So in this third row, representing this third equation, we get a 2, a 1, a 0 for the z, and a 7 for the constant. And that is your matrix form for that system of equations. All right, does anybody have any questions? All right, then your practice for today is going to be on page 179. Problems 8 through 17.